was a snack?
Sure.
Good workout? Good. Now we are going to talk about J2ObjC. It's just abbreviation, don't worry about that. To start with, is there anyone who don't understand anything in development?
Anything what? Anything in development.
Like anything in development who is afraid of code? Good, because it's the last slide with the pictures. The rest is 100 slides with the code.
Generated code.
Generated code.
Okay.
Last chance to leave.
No, actually I'm kidding. There are not much code, so it's very much overview of what we are doing and why we are doing. But before we are going to start, who of you has experience with cross-compilation, cross-platform development? Who had planned to work with Cordova or something like that? Oh, pretty much everyone.
Yeah.
Quite a lot of people, good. So today we are going to talk about alternatives to what we tend to name classical cross-platform development. Now to start with, let's get back to the history and let's get back to 2012 when I met J2ObjC for the first time. In this year, two important events happened. First, we together with friends started Google Developer Group, pretty much the same as Paul is doing here with friends. We started the same in my home city in Ukraine. Second event, J2ObjC was introduced by Google. But in 2012, it was just a command line tool without much documentation, without any real examples. They just released it and and told people, okay, maybe you make something of it. The thing is that I did first presentation because we organized a huge event for 100 people. We were waiting for Google to arrive from Poland, but their flight was cancelled and they had to take a cab and we were delayed for 4 hours. So we had to entertain people for 4 hours and I did my first presentation of J2ObjC. So that's how we started. Next time, I faced J2ObjC at a company called Vitaliy. It's a startup I'm currently working on. When we were looking for a tool to improve our SDK, but more than a little bit later. What we are doing in Vitaliy, just for you to understand what problem did we try to solve. We're building a marketing and communication platform for games and applications. So if you want to let your users chat or let them communicate in activity feed, something like Facebook feed, you can use our library. Put there 2-3 lines of code and you're set. All UI, all the backend, we all handle everything. So basically our company is building a library. And we have our library available now for 4 platforms, but we are going to focus only on Android and iOS. Those are some numbers on what scale we are working, that we are serving like 30 million sessions or users per month, it's quite a lot, and 500 million sessions per year, something like that. But it doesn't matter. We are talking here about development. It was more marketing presentation before. So we have 2 main SDKs. It's iOS SDK and Android SDK. Both of them were built with the native tools. iOS with Objective-C, Android with Java. All other SDKs, like Unity, for instance, is just a thin bridge on top of those 2 libraries that expose API to Unity developers or JavaScript developers in convenient for them way. The good thing about with this approach, when you have 2 absolutely separate SDKs, that you can fully leverage the all platform features. Like you can use native framework to build UI, you can use all networking, like pretty much everything platform will give you to use. The bad thing, as we are building the library and functionality should be exactly the same on both platforms, we are doing work twice. In 2 different languages, but basically we are doing work twice. And second hard thing is to keep our API in sync. Again, if we need exactly the same behavior for both libraries, mainly when we are using them in wrappers like Unity or Cordova, and we require exactly the same behavior. And we know developers are also humans, and each developer is very unique and solve the problems in different ways. And it was often a case for us that main flow, like in ideal situation, for our features was working exactly the same, but in corner cases, behavior was a bit different on iOS and Android, and it was a problem. And we decided, okay, time has come, and you want to recall what Oracle tried to push for last, I guess, 20 years, write once, run everywhere, and go cross-platform. And we started looking for tools to achieve our goal. We reviewed a bunch of them. Most part doesn't work as Xamarin don't allow you to expose your library for Java developers. Ruby, RoboVM is a good, but for application. I'm not going to stop on this because I have only half an hour, but the point is that we selected J2ObjC as the only available solution for us. Now we are going to quickly go what is J2ObjC, what is not, and how we are working with it. Our master plan for today. We will learn what is J2ObjC, we will learn how to set up build, we will learn how development, like how actually writing a code is with J2ObjC for both Android and iOS. And we'll talk about impact on your project. So let's start. What is J2ObjC? Main and probably the most important part to understand is source-to-source compiler. On a previous conference, I got a question. Can I use Kotlin with J2ObjC? No, because J2ObjC is source-to-source compiler. It means that it cross-compiles Java to Objective-C. It cannot do Kotlin to Swift or any other languages. It can do only Java to Objective-C. That's it. No Java bytecode manipulation, anything. Just source-to-source. Next one, J2ObjC is focused only on a business logic. That means that we cannot use it to build the whole application, but we will be able to cross-compile only business logic part as only Java part is cross-compiled, not Android part. And it's open source, which is also nice. When we know what J2ObjC is, now let's talk what it isn't, because there are like a lot of people have background in all kind of cross-platform tools, Cordova or anything else, like all other painful tools. This is also painful, but it gives a bit more advantages as far as. So first, it's not cross-platform application tool. Cordova is a platform to develop write once, and it builds applications to both platforms. With J2ObjC, you can develop only part of your application, your business logic, once, and cross-compile it to different languages. It's important point to understand. Next one, you won't be able to cross-compile UI with J2ObjC. As I mentioned before, it translates only Java code to Objective-C code. No Android SDK to UI kits on iOS, only Java to Objective-C. That's it. It's not Java emulator. Again, it's source to source. There is no Java virtual machine running on iOS, so don't worry about that. And it's not one-time translation. What does it mean? That as soon as you modify your Java source code, your Objective-C code will be changed immediately. It also means that you should not look into what J2ObjC will output on Objective-C side, because it's ugly, and you don't need to modify it because it will be regenerated next time. Is it production ready? Yes. First time when I gave this presentation in Romania, version 1.0 was released 3 days before. And when I was preparing the slides, I said like, it's almost ready, but they actually released just before the conference. So now it's absolutely ready for production use. And probably the most famous case is Inbox. Who is using Inbox? Great. So all of you are using J2ObjC internally on your phone.
Even on Android?
Like, not on Android, but Android project is, like they have one project for like to share the code. So Inbox team managed to share 75% of their whole code base J2ObjC. 75%. Think about this number for a second. It's a lot.
They also included the website in that.
Yep. Like with this approach, with J2ObjC allows them to share 75% of the code between Java and iOS side. With GWT, who knows who is GWT? It's like also source-to-source compiler, but to JavaScript. They managed to do exactly the same, but to JavaScript and build web client that we use in browsers. But besides Inbox, there are tons of other Google apps who are using J2ObjC. Basically, it's calendar or office apps, Google for Business. Google Duo, that was released a couple of days ago, is also using J2ObjC. Besides Google, there are a couple of other companies. In total, I found information about around 25 of them that use J2ObjC as well. And you can see that first one is some kind of library, then application for museum inquiries, then keyword, and other type of projects. What is supported? Because as we can imagine, if it's translations, there should be some kind of limitations. So let's talk about limitations. Actually, there are not that much of them. Full Java 7 syntax is fully supported. Now they are working on Java 8 support. When they started J2ObjC project, they took Java that is on Android as a base for cross-compilation because it was their original intention. So firstly, it was only Java 6 syntax support. Now it's Java 7 syntax support. And since Android latest version moved to OpenJDK, J2ObjC also announced that they're moving to OpenJDK, and Java 8 support is coming soon. Everything that is not available on Objective-C but available on Java, like inner classes, enums, annotations, everything is available for cross-compilation, so pretty much everything should work. But not all reflection works. And what is the worst part? That you won't find easily what part of reflection doesn't work. From our experience, everything works. But they say that in some corner cases, some metadata can be missed. You will find it on your own, but how to avoid that, we'll also talk later. And it also supports Open Objective-C native code embedding, just to show how it looks like. I guess you're familiar with native methods that you can define in Java that is native method, and it will be invoked, for instance, on C side. And you get this you have this declaration, like static native, log, and like method name, and then just semicolon. You don't do implementation. With Objective-C code embedding, you have exactly the same, but in between special parentheses, you put Objective-C code. When translation will happen, this parenthesis will be removed. The signature of the method will be translated to Objective-C style, and everything in between parentheses will be just inserted. So at the end, you will get this method. Like basically, signature of the method is translated to Objective-C side, and everything in between strange parentheses are just injected here. But never do this unless it's absolutely necessary. Every time you are using Objective-C native code embedding, little bunnies die somewhere in the forest. Two reasons why you shouldn't do this. First, it's very hard to maintain and impossible to debug. We are using in our project it in only one place, and it's exactly log. To have cross-platform logging support without too much magic, we use this code embedding. That's pretty much all Objective-C native code embeddings that we have in our project.
So how do you write the Java code that calls the two variants of Objective-C and normal Java? So I assume you have also the normal block statement.
You call just this method? Like,
what happens when you call it on Java code on an Android?
It's implementation of your interface, for instance, and you just call this method. On Java side, you just call this method. You don't care where is the implementation. Is it on Java or Objective-C side? It's just like you call the interface, and where is the implementation, you don't care.
But if there's a native in the declaration of the function, it will basically complain that there's no C++ language.
No, it won't. Not in J2ObjC. I can show you later.
Does it also translate the Java then to normal Java, or?
Once again?
Because if this is Java code, are you basically compiling it directly into your Android app, or does it also convert it to
It's a standalone project. We don't have time to show the demos, but if you're interested after the meetup, I can show you. I have a project here. We can dig deeper into it. Now let's talk about build configuration. For instance, if you have Big Android BBQ Java class, in 2012 we had the only one option how to cross-compile it. we just call J2ObjC command line 2, pass as a parameter this file, and on the output we'll get two files, H and M. That's it. That's everything that was available. All configuration should be passed as a parameter to command line 2, and it was painful as hell. I spent like half an hour to manage to compile Hello World with one library. It wasn't very pleasant, but now things change a lot, and there are plugins available for all popular systems, like build systems, and they also plan to add Bazel support, new fancy Google build system, with the next release. Today we are going to focus on Gradle plugin, because that's the one that is the easiest for Android developers to understand and to work with. The good thing is that it was written by two extremely smart guys. They are both ex-Google engineers, and they were doing it on their spare time. It's super easy to integrate it, just like any other Gradle plugin. It has perfect documentation. If you look into code base, it's really state of art. Everything is perfect, like you have perfect test coverage, it's perfectly documented, ideal code structure. You look into it and you basically understand it. But there is a bad side of this plugin. As of last month, it's not supported. Those guys doesn't have much time, and the project is now looking for a main maintainer. There is one guy that wants to claim it, but Bruno wants to test him if he's good enough for this plugin. So we'll see. But we created a fork of the plugin like half a year ago, because it wasn't maintained actively for more or less half a year. So if you want to use latest J2ObjC features, come to our fork. The link will be posted later. The latest supported, officially latest supported version by the plugin is some pre-release version. That was the main reason why we had to create our own fork. And the biggest problem is that the latest Gradle version, supported Gradle version, is 2.8. If you are working with Android actively, you saw this annoying pop-up in Android Studio. Please upgrade your project to latest version of Gradle. And if you will press that button, you will break J2ObjC build. Because in Gradle 2.8, they introduced new project model that is not compatible with J2ObjC Gradle plugin. Basically, the first task for a new maintainer will be to rewrite plugin. There's quite a bunch of codes that need to be written to a new project model based on rules, and allow to use latest version of Android Gradle plugin. Now we are stuck on 1.6 Android Gradle plugin just because of J2ObjC, which is not that bad. It is working. And you can check our fork here. When you are setting up iOS project, if you are just doing a basic application and you have a business logic part, you have UI part of your application, and you want to build just UI part of iOS application, everything is pretty simple. J2ObjC Gradle plugin automatically generates Cocoa pods for you, automatically configures Cocoa pods in your project, so you don't have to do anything.
And Carthage?
Handles you for everything.
How about Carthage?
What?
Carthage, it is like an alternative to Cocoa pods.
No, they support only Cocoa pods. Or you can include libraries manually. If you are a little bit more geeky and you want to have like full control of what is happening, you can include your libraries manually and to configure the Xcode project where to find the libraries. But none of these approaches were working for us, mainly because we were not able to debug Objective-C part. To explain why. In both of these approaches, like when we include generated code via Cocoa pods or manually linked libraries, in any case we link a static library. And what static library means on iOS side, that you don't have any source code, it just exposes public headers, and the rest is binaries. So we were not able to debug our source code. It's not recommended, but from time to time we were very curious what is happening inside. And it was impossible for us to do. Compilation process, to picture it better for you. Compilation process looks like this. We have Java source code on the first step, it's translated to Objective-C source, then it's compiled to static library, and then included automatically into your Xcode project. What our iOS engineers did, they wrote a small Python script that after running, like generating static library, it took Objective-C sources from a previous step and generated Objective-C project that was included and linked into our project structure. With this approach, we were able to debug. Oh, it was good. We achieved our goal. One more important thing about builds, they are slow, and you want to optimize. Our small library, okay, it's not small, but our library in initial stages took 6 minutes to cross-compile, like to build Android part and cross-compile to Objective-C part without building iOS project. 6 minutes. What we did to optimize this build time? First, we disabled release builds. As Android, iOS has the same option for debug and release builds. So for development, you don't need release builds. You cut off, like, maybe not half, but a third of the build time just by disabling release builds. It's also just one flag in J2ObjC Gradle plugin. Next one, on iOS, we have multiple architecture. I have only 5 minutes. A good idea is to include only target architectures that you are going to use. For instance, if you are building only for simulator, if you are testing only on your iOS simulator, not real devices, you don't need to build for like architectures for real devices, like for 64-bit architecture or RAM 32-bit. You just need to build for a simulator. It will also save you some time. And when you are working only on Android part of the project, make sure you will be able to disable J2ObjC cross-compilation. There is no like magic flag to do so, so you will have to set up your Gradle build with some like button to disable J2ObjC build. And we want to do one more optimization. We thought, okay, if we are not including static library, why do we need to build it? We can just like break on this point and include Objective-C sources right away. But it doesn't work. And okay, it works, but we lose ability to run our tests on Objective-C side. The point is that besides cross-compiling Java source code, we also cross-compile all our unit tests. And on this step, we just generate Objective-C code. Actually, execution of unit tests on Objective-C sites happens after static library generation. So if you want to ensure that your code is working properly on Objective-C site, you need to build static library and run tests on static library. So this step is mandatory. But that's one thing that we figured out yesterday. For a static library to run tests, you don't need to build all processor architectures, that's just one for simulator. So, and with all those optimizations, we cut our build time from 6 minutes to less than 2. For development process, I'm going to skip project structure because you can check it in official repo. There's nothing special. You have Android, iOS, and shared module, which this part is cross-compiled, and this is platform-specific modules. It's our specific part. I don't have time for that. You know this guy. Like the guy. Who knows this guy? Come on, it's not Jack Wharton. It's Uncle Bob. Jack Wharton is not that crazy. So that's the creator of tuning architecture, and the good thing about J2ObjC is that J2ObjC enforces you to build a proper architecture, because won't use that or not, your business logic will be separated. And won't use that or not, you will have boundaries of your application. It's just what tuning architecture states. It's how it's projected to your project structure. We're also going to skip this. Important one about dependency management. We are all lazy developers. We don't want to write the same functionality twice. We all like libraries. To include libraries when you're working with J2ObjC is not always easy, because you have to comply with a couple of factors. First one, you have to have sources, because you need to, again, source to source cross-compilation. So if you want to cross-compile a library, you have to have sources of the library. So forget about any proprietary libraries that distribute only jobs. Next.
Using decompiled Java code
No.
and then compiling.
If you'll be able to build the compiled codes, then maybe. But I really doubt that. Not all Java packages are implemented. Some parts of Java security and Java Neo are missing from J2ObjC. Like Java security is missing from security point of view because they cannot ensure that it's secure enough after cross compilation. Neo is missing because it's missing on Android. And tests are highly recommended. Like when you cross-compile libraries, to make sure your cross-compiled code is working after cross-compilation, you need to cross-compile tests and run them as well. Gradle plugin allows you to do it easily. For instance, if you want to cross-compile Google JSON library for JSON manipulation, you just specify it as a dependency as you used to, and in J2ObjC Gradle coughing, you just say, do the magic, true. And it will automatically fetch the sources, fetch the tests, set up all the cross-compilation class passes, and do the magic. But we managed to set it up only for JSON, not any other library. It's a nice feature, but it very rarely works. Most likely you will set up something like this. You will actually get the sources of the library, or ask Gradle to do it automatically for you. You'll create a separate project for RX Java, for instance, set up cross-compilation in this build Gradle file, and include project into your shed, like include RX project into your shed module. And then plugin will also handle all the copying properly cross-compiled parts. So it's not that hard, it just requires extra stuff. From libraries that are officially supported, and on an official website you can say that yes, you can use this library safely. Everything we need for testing like JUnit, Hamcrest, Mockito, all loved by Google, Protobuf, Guava, and JSON, and some other libraries. The one thing that a couple libraries that personally our team was missing was AssertJ. We actually don't like Hamcrest, but we used to use AssertJ, but you cannot use it. Regarding RX Java, like we are on RX events, and probably it's relevant. Kind of. RX Java is not officially supported because when you cross-compile it with all tests on Objective-C side fails. There are a couple of reasons for that. Some of them are just bugs in J2ObjC with threading. Don't worry, it's just in test. So what we did, we are not using, as we are building SDK, we are fighting for every thousand of methods. And RX Java is quite a big library, so what we did, we just stripped the part of RX Java that we are using, basically just schedulers, framework, and subscribers. And we do cross-compilation only of this part together with tests. Tests for this part are working. So for us it's working, we hope it's safe. We didn't find any issues on Objective-C side, but officially it's not supported because of test cases. But there are communities working on that to update RX Java to support with J2ObjC. And you can check which libraries are supported in this Gradle repo. They set it up Travis C continuous integration to validate that all new libraries, like all new versions of supported libraries are properly working on J2ObjC side. The good thing about J2ObjC is that unit tests is, as I said, they are, if you want to make sure that your code is working properly on Objective-C side, you'd better write unit tests. The bad part, that's the only way to validate your J2ObjC code working properly. So if you want to have 100% reliability on your Objective-C side, you have to have a goal like 100% coverage of your code. So we know that 100% is nothing. It's more about logic you cover, but that's the goal you have to have. For testing, we have everything we need. We have testing framework, mocking framework, assertion framework. They are all old, but they are working. They are trusted by the community. What can we do? The bad thing with tests, there are some issues. Like I mentioned, particularly with RX Java, is this problem. they're using thread sleep somewhere in their tests and it's failing. It just hangs up the thread and tests do fail. J2ObjC Gradle plugin has issues with distinguishing which classes are just utility classes, which are tests. So you have to, like what we did, we created a convention that all classes that contain tests have suffix test at the end, and we can say in a plugin that run tests only classes that have suffix test. All our util classes just don't have this suffix, and we are good. And narrow selection of testing libraries. There are JUnit 5 coming soon. There are much better sortation frameworks than Hamcrest, but we won't be able to use them with J2ObjC. Now let's talk about J2ObjC site on iOS, about iOS developers. Are there any iOS developers here? Okay. Now we are going to... Yes, we can. Okay. If Java developers has nice methods like this, J2ObjC developers have pain like this.
Oh.
Mainly because J2ObjC doesn't have namespaces, and namespaces has to be embedded into class names to avoid collisions. J2ObjC provides like the same with methods. J2ObjC provides a couple of tools to solve this problem. First one is annotation that you can put on top of your method or class and say how Objective-C class or method should be named. It provides, you can provide mappings for packages and for methods, but don't use mappings for methods because they are very fragile. Mainly because you have to specify method signature in just properties file, and it's the first problem, and when you go into refactor Java side, you're going to break your properties file. And it's not very easy to read because it's GNI signature. There are more problems, but we don't have time for that. If you are interested, iOS developers, I'm here. Well, what we're using at our company, we use package prefixes to cut off this long prefixes for packages and set of wrappers. Basically, what around all generated code, we have Objective-C wrapper that exposes like, Objective-C readable API to the rest of the developers. And quickly about project impact. It's tests not by us, but some other third-party developer. It's CPU performance. J2ObjC is fast. If you compare to first versions of Swift, it's even faster than Swift. I'm not even talking about other cross-compilation tools. So don't worry about the speed. Why? Because we compile Objective-C and nothing else. It's no virtual machine running or anything. It's just the same Objective-C code, but generated and handwritten. Regarding memory performance, it's on the same level as Swift, so you also should not consider this as a problem like memory performance. Regarding size impact, as you understand, you cross-compile code, but to make sure all Java API is working, besides cross-compiling your code, Java runtime environment should also need to be cross-compiled. And that's where 3 megabytes of extra size to your application comes from. Which is not that bad. Like 3 megabytes to share 75% of the code, it's quite a good number. You can reduce size in 2 ways. First one is in latest version of J2ObjC, you can include only parts of Java runtime environment, the one you are using. Questions after, because we don't have time.
I was waiting to
And second, you can shrink code with ProGuard. But you're not going to actually shrink Java code. You're going to, ProGuard will generate you report which classes are unused. You put, and you feed this report to J2ObjC, and J2ObjC, based on ProGuard report, will cut off unused classes.
Jump to the conclusion.
It's the last slide.
Okay, cool.
And team impact. If you have equal Scrum team, like Scrum says that our team should be balanced. We should have the same, equal power between iOS, Android, backend developers. Most likely you have to fire some of iOS developers after this, or give them some other job. Like our iOS developers started to write Android. And all new hirings that you're going to do, you have to check they have to have a primary knowledge of the platform, it's Android or iOS, but they should also know the second platform. Because if they want this or not, they will be forced to work with both platforms in the same project. So is it a silver bullet? How do you think? Is it ideal solution for any single situation? Yeah, it really depends. In our case, for Get Social, for building library, it saved our ass. It solved all our problems. We got performant library. We are using all platform features to allow smooth UI. We don't have any big problems with size impacts. 3 megabytes is meaningful, like it's reasonable size, and it's open source. So it means that it won't cause any licensing problems for us as a library developers. Is it the silver bullet for you? It's decided up to you. If you have any questions or recommendations about working with J2ObjC, I am here. Here are my contacts. Slides are available on my website. Thank you for your attention, and all questions after the meeting.
Thanks, Vitaliy. Sorry to rush you.
That's fine. I can get excited with this presentation.
I can imagine. Well, kind of setting up.
You can just put on top.
Yeah. We have some...